Welcome back to the morning show. Coming up on 6:50, and it's Wednesday. That means it's time for a little science. Jesse Miller from the U of I is back, and we got to have a name for your segment.
Yeah, I know. I've been running things through my head.
Yeah, we have Chemist Corner that we're throwing around. So, okay, got some ideas from viewers. If you want to name the segment, just send us an email, morningshow@wci.com. All right, Mr. Miller, today talking about density.
That's right. So, like around 70 A.D., you know, you've heard of Archimedes, right?
Sure.
And the story goes that he was commissioned by the king, or the king had some gold that he wanted a crown made out of. Mm-hmm. And so back then, some of the disreputable workers would cut their gold with copper. And the king wanted to figure out a way that he could make sure that it was all the gold.
Sure.
And they didn't really have any way to do that, so he told Archimedes, well, you're a pretty smart guy.
You figure it out.
You figure it out, right? And so he angsted over this, and then the story goes that he got in the tub and noticed that the water rose when he got in the tub, and he said, hey, Eureka, right?
There you go.
And came up with this concept of density, which is basically the mass of something divided by its volume. Okay. Something can have the same volume, but it's heavier, it'll be more dense. Mm-hmm. Okay, so we can show this with these two Coke cans. Okay. You got a Diet Coke and you got a Coke. Okay, which one do you think is going to float and which one do you think is going to sink?
I would say this one's going to sink. Because that one's diet.
Okay, well,
no scientific reasoning behind it. Just reading the label.
Well, that's a pretty good guess, and it's actually a pretty good explanation. And we'll see here, okay, that the Coke can actually does indeed sink, and the Diet Coke does float. Very good, very good. Now, the reason for that is because the Coke has a lot of sugar in it, or fructose corn syrup, right? But it's pretty thick, and it's a lot denser than water. Diet Coke is pretty much just flavored water.
Pretty much.
I mean, there's really not much to it. So and aluminum's not very heavy, and there's enough air in there to where it'll float, and the Coke doesn't. So that's one way. You can make just about anything float if you displace. If the amount of water that you're displacing is lighter than your object, then it'll float. So we can take some aluminum foil here, and I'm not a very good artist.
You didn't study origami or anything?
No, I should have got my daughter to come in here. She's pretty good at this. But we can make a boat, sort of. I mean, it's got a boat shape to it at least.
Sure, close enough.
And, you know, even though this is metal, it should float because the amount of water that it's displacing is greater than the weight of the boat. Now, if we crumple it up, it should sink, right?
It should.
No, it's not gonna. Right? And it's not going to because aluminum is pretty light and there's still a lot of air in there. If we want to make that sink,
2 for 2 this morning.
If we want to make that sink, what we need to do is remove all the air out of there. So we're just going to fold this up nice and tight. And of course, you know, kids, you're in the bathtub or whatever, you can take all sorts of things in there and see if they float. Yeah. Play around with it.
Experiment with your bathtub.
You can make, you're right. You can make boats out of clay. I wouldn't make them out of Play-Doh because Play-Doh kind of...
well, that'd be messy.
Yeah, that'd be real messy. But see, if I get enough air out of this, it's the same size, and yeah, there you go. So it sinks now.
Very cool. Very cool experiments.
Now, the last thing, you know, a lot of times you get Mylar balloons, and then after a couple of days, they kind of go flat. This one still floats a little bit because I just wanted to get it to where it's just barely floating. But but if we want this to really float, now, liquids and solids don't change their density very much with temperature. But gases do. Gases will expand, and the density will change. And helium floats because it's lighter than air, right? So it's less dense than air for the same volume. But if we are able to increase the volume by heating it up, the gas gets excited, this balloon should expand, and we should be able to float it across the room. Now, this hairdryer, of course, I had to steal. But,
all right, let's see it.
Hopefully we can get this hot enough here. Melting it.
Yeah, that's a good point.
Should get it afloat. There we go.
Very cool.
Eventually it'll come back down again.
All right, very nice. Well, thank you very much. We'll come back in 30 minutes and we'll